Okay, Math 95. I'm going to finish up with two more examples from the homework for section 8.2 in the Hawks. So here's another problem that I had on Hawks. Solve the systems of equations using the substitution method. So again, I want to look for where there's a variable, an x, and we're only dealing with x and y. So I see I have a y standing alone here, but I would have to get that y alone. Here, the y is already alone, so I'm going to use this equation. I don't have to solve for it. The y is already alone by himself. So I know that y equals negative 6x plus 8. So I'm going to use the substitution method, and I'm going to plug that in here for y. I'm going to substitute it in. So I'm going to write 6x. I know y equals this. Just plugging that in and writing everything else down. So this is 6x, this is y, because y equals negative 6x plus 28 equals 20. Okay, if you look, what's going to happen with the x's? They're going to cancel out, right? And all I'm left with is 28 on one side and 20 on the other. Well, does 28 ever equal 20? Is that true? No. So when I get down to two numbers that are not equal, let me write that on here. When you are left with two numbers that are not equal, our answer is no solution. These two lines have got jack squat nothing in common. So you're just going to check on Hawks. They're going to give you the three. They're going to give you one solution, no solution, infinitely many solutions. You're just going to check off no solution and you're done. That's all there is to it. Easy. Okay, so let me do one more example. So I've done one solution where the lines meet up, or the linear equations have one point in common. If they're two lines, they meet up in one point, like you saw in 8.1, where you drew the lines out and they met up in one point. That's one solution. Here, these lines have nothing in common, so they got nothing in common. They're going to run parallel. They don't meet up at all. Okay, here's the last one I'm going to do. And I want to solve the system Okay, so they want you to use substitution, so that's what we're going to do. But when we've learned all the methods, I'm not going to say which method to use. You can use whichever method you want. So going back to the very first problem, and a little hint was, is there anything you can divide out of either of these two? Well, I'm looking here and I'm seeing a 3 can go into all of these. So I'm going to take that top one. Let me rewrite these. I'm going to take that top one and I'm going to divide it, the whole thing, by 3. Okay, so I get negative x, and I'm going to bring this one underneath it. Well, I can tell right now what's going on. Maybe you can't. If you see that they're equal, you know something's up. So let me just finish it out though. But if you see that they both equations are matching up, we know it's infinitely many solutions. I'll say if but I'll finish it out. I'll show you what happens. Okay, so both of these y's are by itself. I got a negative, they're here by themselves, the x's, but they have a negative in front. So I'm just gonna, I could take either one. I'm gonna solve for y, get y by itself. So I'm going to add x to both sides. And I'm going to bring the x up front. So I can't put the 9 and the x together. They are numbers and letters, so it's just I tack them on. I join them with a plus, so y equals x plus 9. I'm going to take that and I'm going to go ahead and substitute this in right here for y, and I'll let you see what's going to happen. So y is x plus 9. These two cancel out. I get 9 equals 9. So when the numbers are equal to each other, 9 equals 9, this is true. This means my answer is infinitely many. Which means the lines meet up everywhere. It's like one line laying on top of another line, and they meet up everywhere. They have infinitely many points in common. So you would check infinitely many solutions. So when the two equations come down to two numbers that are equal, could be 0 equals 0, 10 equals 10, that's infinitely many. They intersect on both lines everywhere, in infinitely many places. So I hope that helps with substitution. Again, let me know if you need to see more problems. I can always do another video. I hope that helps you do the homework. Okay?